February 20th, 1943, north of the Kasserine Pass, Tunisia. No battle report could ever fully capture what German tank commanders witnessed that morning. American Sherman tanks were performing maneuvers that defied everything Wehrmacht doctrine claimed was possible without visual signals. Through the dust and smoke of the North African battlefield, 5 Shermans, separated by rough terrain and lacking any line of sight between them, converged on German positions with timing that seemed almost supernatural. No flags, no flares, no messengers running between vehicles. Yet they moved as a single organism, each tank covering the blind spots of the others, every crew seemingly aware of the exact position of its companions. Inside the German Panzer IVs, equipped with WWII radios, commanders struggled to hear even their company leaders through the static that flooded their amplitude modulation systems. The 10-watt German transmitters, cutting edge by 1930s standards, could barely reach a few hundred meters when the tanks were in motion. Most German vehicles carried only receivers and could neither report what they saw nor call for help. The Americans, by contrast, were operating with technology whose very existence the Germans did not yet suspect. Frequency-modulated radios in every tank, crystal-controlled precision, 25 watts of transmission power, and clarity that sliced through engine noise and battlefield chaos like a knife through paper. 8,000 miles from the assembly lines of Detroit, the most decisive technological advantage of the Second World War was revealing itself, not in the thickness of armor or the caliber of the gun, but in the invisible electromagnetic waves that bound every American tank crew into a single, coherent fighting organism. Origins of the American FM radio advantage. The transformation began on July 22, 1941, when the United States Army standardized the SCR-508, SCR-528, and SCR-538 radio sets for all medium tanks. While German forces were advancing deep into the Soviet Union using tactics dependent on limited radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render the German systems obsolete. The engineering team included Daniel E. Noble, who conceived the application of FM technology to military vehicles, and Henryk Magnuski, the lead RF engineer who overcame the immense technical challenges of installing sophisticated electronics in the harsh environment of an armored vehicle. Their creation weighed 181 pounds and transformed each Sherman tank into a node of the world, S first true battlefield communication network. The BC-604 transmitter generated 25 watts of power, 2.5 times the output of the German WWII. Operating within the 20.0 to 27.9 MHz frequency range, it provided 10 preset channels with crystal-controlled stability. Dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat. Yet the true revolution lay in the modulation itself. The FM technology developed by Edwin Armstrong, licensed for military use, eliminated the static and interference that plagued amplitude-modulated systems. While German tank radios captured every electrical discharge as noise, American FM sets delivered clear voice communication even during heavy artillery bombardments. Combat demonstrations, North Africa to Italy. On November 8, 1942, Operation Torch brought American armored forces to North Africa. Tanks of the U.S. 2nd Armored Division landed near Safi and Fadala, equipped with SCR-508 radios that would soon demonstrate their superiority over German communications. The Afrika Korps, despite being the most experienced armored force in the Wehrmacht, operated under severe communication constraints. A standard German tank platoon of 5 vehicles typically included only 1 or 2 equipped with full WWII transceivers capable of both transmitting and receiving. The remaining tanks carried WWII receivers only. They could hear orders but not reply or report enemy positions. German platoons thus functioned within a rigid hierarchy. The platoon leader transmitted commands that subordinate tanks acknowledged through actions rather than words. When command tanks, easily identifiable by their multiple antennas, were destroyed, entire platoons lost coordination. This vulnerability would prove catastrophic against American forces, where every tank could assume command functions. The Battle of Kasserine Pass, February 14–24, 1943, offered the first major demonstration of American radio superiority. Though tactically a German victory, the engagement revealed capabilities that astonished Wehrmacht observers. Amid the confusion of battle, scattered elements of the U.S. 1st Armored Division maintained coordination across nearly 80 kilometers of battlefield. Tank crews, many of them in combat for the first time, warned each other of threats and called for artillery support through crisp FM communications. German signals intelligence units intercepted American transmissions and were struck by their clarity and precision. The intelligence section of the 10th Panzer Division reported that U.S. units maintained effective communication at distances where German radios produced only static. Even more unsettling was the realization that every American tank appeared capable of full transmission, not just command vehicles. The German FUG-5 radios, operating on amplitude modulation within the 27.0–33.3 MHz range, suffered from fundamental limitations. Their 10-watt transmitters struggled to reach 2 or 3 kilometers under ideal conditions, and their range dropped to mere hundreds of meters when moving. Every spark plug ignition, every electric motor, every track movement generated interference that AM systems could not filter. By September 1943, American armor had reached Italy, where mountainous terrain should have negated radio advantages. Instead, FM technology proved even more valuable in conditions that rendered German AM sets nearly useless. The frequency modulation of the SCR-508 handled multipath interference from valleys far better than amplitude modulation. American tanks coordinated movements across terrain where visual signals were impossible, while German radios failed completely during the advance toward Cassino. U.S. armored units demonstrated levels of coordination that defied German understanding. Tank platoons separated by ridgelines executed attacks with precision that German doctrine deemed impossible without direct line of sight. After-action reports from the 1st Armored Division described routine coordination at ranges where German radios produced nothing but static. From Normandy to Cobra, June 6, 1944. As Sherman tanks rolled off landing craft onto the beaches of Normandy, their SCR-508 radios maintained contact with naval gunfire support, a level of coordination impossible with German technology. Yet the fighting in the Norman hedgerows soon exposed a critical flaw. Tank radios could not communicate directly with infantry radios, which operated on entirely different frequency bands. The infantry's SCR-300 operated between 40.0 and 48.0 MHz, incompatible with the 20.0–27.9 MHz range used by tank radios. This communication gap proved deadly at Bocage, where German infantry armed with Panzerfausts could approach American tanks undetected, while nearby U.S. infantry had no way to warn them. American innovation closed this gap within weeks. Tank crews mounted EE-8 field telephones in ammunition boxes welded to the outside of their vehicles and connected directly to the internal intercom. By the time of Operation Cobra in late July 1944, this simple modification had revolutionized tank infantry cooperation. Between July 25 and 30, 1944, Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated more than 200 Sherman tanks through radio networks that allowed unprecedented battlefield control. The German defenders of the Panzer Lehr Division faced an enemy that seemed to possess an almost supernatural awareness. American tanks reacted instantly to threats reported by other units kilometers away. Artillery strikes coordinated through tank radios followed within minutes of target identification. The contrast with German capabilities was stark. Once the premier armored formation of the Reich, Panzer Lehr had by then been reduced to poverty in communications. Most of its tanks operated without radios, relying instead on visual signals in terrain where visibility rarely exceeded 100 meters. The few radios that remained functional suffered from interference and limited range, making effective coordination nearly impossible. The irony was profound. Germany had pioneered the use of radio in armored warfare. Heinz Guderian, architect of the Blitzkrieg, had insisted since the 1920s that all tanks be equipped with radios. His 1937 book, Achtung, Panzer, emphasized communication as essential to armored operations. Guderian himself had developed early radio coordination systems for tank officers, recognizing that rapid movement in mechanized warfare required reliable communication. Yet by 1943, German tank production could no longer supply the radios that Guderian's own doctrine demanded. Industrial and technological superiority production statistics revealed the crisis facing German armored forces. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Many radios were allocated to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Soviet armored forces suffered even more severe communication deficits. The T-34, despite being the most produced Allied tank, often went into battle without any radio equipment. Soviet doctrine relied on flag signals and pre-combat planning, resulting in catastrophic outcomes against German forces in 1941. By 1943, Lend-Lease provided some relief, as American radios, including SCR-508 sets, equipped Soviet command tanks. Even so, by the war's end, only around 25% of Soviet tanks carried radios. This contrast highlighted American achievements. While the Soviet Union struggled to equip a quarter of its tanks with radios, the United States implemented FM systems in 100% of its Shermans. Motorola's Chicago factory exemplified the peak of American industrial mobilization. Before the war, the company produced car radios. The transition to military production required a complete restructuring and the solution of unprecedented technical challenges. Each SCR-508 contained 2,748 individual components, manufactured to exacting standards. The BC-604 transmitter alone housed 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability under extreme temperatures and vibration. Production statistics reflected the scale of American industrial power. 1942, 3,800 SCR-508 radios produced. 1943, 11,400 units. 1944, 24,000 units. Total wartime production, over 50,000 radio sets for tanks. This production miracle ensured that all 49,324 Sherman tanks built during the war were equipped with sophisticated radios, a level of deployment unmatched by any other nation. The advantages of the SCR-508 extended beyond simple frequency modulation. Crystal-controlled frequency stability meant that channels could be preset before battle and remain accurate even under combat conditions. German FUG-5 radios, using variable capacitor tuning, constantly drifted off frequency. Dual receiver setups allowed commanders to monitor both platoon networks and company command networks simultaneously. Orders flowed instantly through the chain of command, while commanders maintained awareness of subordinate positions. The BC-606 intercom system integrated seamlessly with the radio, enabling every crew member to alert the commander to threats. Throat microphones and noise-canceling headphones ensured clear communication under fire. Many German tanks lacked intercom systems entirely, forcing crews to communicate by touch or shouted commands. Power management provided yet another advantage. The SCR-508 operated on 12 or 24 volts, automatically adjusting to available power. The motor-driven dynamo supplied filtered, stable energy, eliminating electrical interference. German radios, powered directly from vehicle electrical systems, picked up every spark as static. Command flexibility and tactical transformation. The tactical deployment of universally equipped radios transformed American armored doctrine. The combat command structure, task forces flexibly organized for specific missions, relied entirely on reliable communications. American commanders could assemble ad hoc battle groups from different units, confident they could coordinate through compatible radios. This flexibility confounded German commanders accustomed to rigid organizational structures necessitated by limited communication capabilities. During the Battle of Ericourt in September 1944, the U.S. 4th Armored Division faced multiple German Panzer brigades equipped with superior Panther tanks. The Germans held all the advantages in armor and firepower, but American radio coordination proved decisive. Any Sherman could instantly report enemy positions. Tank destroyers received targeting information from Shermans that could not see the enemy themselves. Artillery observers in command. Shermans called in devastating barrages within minutes. Over a 3-week period, the 4th Armored Division destroyed 281 German armored vehicles while losing only 41 Shermans, a kill ratio of 7.1, defying the technical specifications of the vehicles. Throughout the war, German intelligence failed to grasp the importance of American communication superiority. Combat reports noted American coordination, but attributed it to training rather than technology. A captured intelligence assessment from September 1944 stated, U.S. tank units demonstrate good discipline and radio coordination. This appears to result from extensive training and rigid communication procedures. The report entirely overlooked the technological advantage. German tactics never adapted to American capabilities. They continued targeting supposed command tanks based on antenna configurations, unaware that every Sherman could coordinate responses across the battlefield. They planned ambushes expecting that American tanks would lose coordination when separated, failing to realize that radio contact maintained unit cohesion even without visual contact. By March 1945, as U.S. forces approached the Rhine, their communication superiority reached its zenith. The capture of the Remagen Bridge showcased the speed of American command and control. When the 9th Armored Division discovered the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the front were moving to exploit the opportunity. German forces, dependent on telephone lines systematically destroyed by U.S. aircraft, could not respond with comparable speed. American radio coordination created an almost impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires across radio networks. German counterattacks, poorly coordinated due to communication failures, were destroyed in detail. German misinterpretation and the endgame. By April 1945, the encirclement of the Rhine pocket demonstrated the culmination of American communication superiority. U.S. armored columns of the WWII and 9th Armies coordinated a complex double envelopment entirely through radio communications. Within the pocket, 325,000 German soldiers found themselves trapped, in part because their communications had collapsed. U.S. fighter bombers, guided by radio-equipped forward controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and with one another. The last messages from Field Marshal Walter Model before communications failed highlighted the dire situation. No contact with adjacent units, no communication with higher command. Fighting continues, but coordination is impossible. American radio superiority profoundly shaped the psychological experience of armored warfare. U.S. crews fought with the certainty that they were never alone. Even when physically isolated, they remained connected through electromagnetic waves. German tank crews experienced the opposite, deep isolation. Unable to communicate, they fought individual battles within larger engagements. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir Tigers in the Mud about the challenges of limited communications, though he focused more on tactical aspects than on the communication gap itself. The strategic implications extended beyond individual engagements. U.S. advances between 1944 and 1945 relied in part on radio coordination that German forces could not match. The Third Army AQ's march across France depended on radio networks that maintained control over hundreds of miles. German commanders consistently underestimated American capabilities because they could not conceive of the communication superiority possessed by U.S. forces. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but could not resolve it. In a December 1944 memorandum, he acknowledged that American coordination nullified German advantages in tank quality. After Germany's surrender, U.S. technical intelligence evaluated German equipment. Their findings confirmed what combat experience had already suggested. German tanks often had superior armor and firepower, but catastrophically inferior communications. U.S. Army Technical Intelligence Report 176 concluded that German tank communications lagged approximately 5 years behind U.S. systems. The absence of frequency modulation, limited radio distribution, and poor electrical shielding created critical vulnerabilities. Soviet evaluators reached similar conclusions. With captured German equipment, the Red Army chose to replicate American radio designs rather than German systems for post-war development. Psychological and strategic implications. Production and deployment statistics highlight the scale of the American achievement. U.S. radio production, SCR 508 to 528 to 538 family. Over 50,000 units. Sherman tanks produced 49,224 units. Radio deployment rate 100%. Transmission power 25W crystal-controlled frequency stability plus 0.01%. Mobile range 7 miles. Stationary range 10-15 miles. German FUG-5 transceiver production 6,000 units. Medium and heavy tanks produced 12,000 units. Transceiver deployment rate 20%. Transmission power 10W. Frequency stability plus 1%. Mobile range 0.5 to 1 mile. Stationary range 2 to 3 miles. Mission response times. American fire missions 3 to 5 minutes. German fire missions 15 to 30 minutes. American tanks achieved 100% coordination, whereas only about 20% of German tanks had full communication capability. The radio superiority of Sherman tanks established principles that still govern modern armored warfare. Today's main battle tanks carry communication suites tracing their lineage directly to the SCR 508, now digital, based on the same principles of universal deployment and reliable coordination. The post-war German Army, rebuilt in the 1950s, prioritized communications based on lessons learned in WWII. Every Leopard tank produced was equipped with full radio systems. A Bundeswehr training manual explicitly states, "The defeat of superior German tanks by inferior American vehicles equipped with superior radios demonstrates that information dominance surpasses platform superiority." Modern conflicts validate this lesson. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks, but with inferior radios. In 2003, U.S. forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of American Sherman radio superiority represents a victory in the electromagnetic spectrum, one more decisive than advantages in armor or firepower. German crews fought partially blind to this revolution. They discovered too late that each Sherman tank was not just a combat vehicle, but a node in the first true battlefield network. The SCR 508 radio transformed the Sherman from a capable medium tank into a component of a system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower. Each Sherman carried the tools of victory, not merely a 75 mm gun or sloped armor, but 82 kilograms of radio equipment connecting its crew to other Sherman crews. This connection created a collective intelligence that no German tank, regardless of its armor or firepower superiority, could match. Legacy and doctrinal transformation. German forces discovered this reality through bitter experience. At Kasserine Pass, in the Italian mountains, through the French hedgerows, and in the final battles on German soil, American tanks demonstrated coordination that German doctrine considered impossible without visual contact. The Wehrmacht never developed an effective countermeasure because it never fully understood the technological gap. Field Marshal Wilhelm Keitel, S. Remark upon Germany, S. Surrender. We knew how to build better tanks, but you knew how to make them work together, captured a fundamental truth, whether accurately cited or apocryphal. The United States had built not just 49,324 Sherman tanks, but 49,324 nodes in the first armored battlefield network in history. The military revolution that historians identify with modern network-centric warfare began in 1942 when the first Sherman tank equipped with the SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications defeated the side with superior weapons. Networks prevailed over platforms, and the connected overcame the isolated. This transformation largely occurred invisibly to German forces. They observed American tactical superiority but did not recognize its technological foundation until it was too late. By the time German commanders realized that each Sherman possessed communication capabilities most German tanks lacked, the war was practically decided. The German Army's failure to recognize and adapt to American communication superiority is considered one of the great intelligence failures of World War II. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized resolving its critical communications weakness. They continued building individually superior tanks that fought in isolation, while U.S. forces produced adequate tanks that fought as coordinated teams. In the end, the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing shells fired from German 88 mm guns. The ability to coordinate, share information instantly, and fight as a unified force rather than as individual vehicles determined victory more reliably than any visible superiority in armor or armament. Sherman radio superiority changed warfare forever, establishing the principle that in modern combat, connection equals survival, while isolation equals defeat. German troops learned this lesson on battlefields across 3 continents, discovering too late that Americans possessed not only numerical superiority, but also technological dominance in the dimension that mattered most: the ability to fight as a unified force.